All right, on page 266, this is what I'll assign. This will be due for Tuesday, all right? I want you guys to do problems. Why do you do problems 1 through 19? And then number 21. And we'll make this due for Tuesday. Yeah.
Do you have an eraser to go on like a pencil?
If you want to check the center drawer of my desk, you might have to dig around a little bit. There might be one in there. Not real sure. All right, so go ahead and take a second and get that written down, please.
Well, that's cool. You did that.
Just grab one of those extra pencils in the cup over there and use that eraser, okay?
Okay.
Did you find it?
Are these gonna smudge them?
I have no idea.
I got a feeling they might. Make you search. I know Brian does.
Why don't you run in there? She's on prep right now. All right, you guys have this down right here? Everybody have that down? All right, let's rock and roll this today. This isn't going to take too terribly long to get through today, so give me your undivided attention. It's our last Friday of the year. Okay.
There's not?
When you go in there, say, why is you locking the door all the time?
Why is you locking the door all the time? Okay. Wait, what will you say?
I'll stand by. I'll just stand behind them.
Okay.
What do you say?
Why is you locking
All right,
the door?
straight face it now. Come on, just get it together. Focus.
Izzy can't do it.
Focus.
Send someone else.
Hit it.
Send someone else.
Deep breath. Focus. Go.
Hey, ask her if she
No,
got
I
my
seen
leg.
that the door was broken.
Ask her if she got my leg.
Now, what is you?
Why is you locking the doors?
This is my little She ain't like me. Watch this one. Watch this one. She ain't got no respect for me. All right, let's roll.
Did we lose Izzy in the battle?
No, Izzy's still on my side. All right, here we go. Guys, 5.4, we're going to kind of be doing a lot of the same things that we've been looking at, solving equations and stuff, but we're going to start looking at inequalities. We've kind of talked about inequalities a little bit in the past. I have a question right here. If I put this up here as a solution for something that we're going to have as an answer, like x is greater than 2, be some kind of a solution we're going to start looking at. Give me some values that I could substitute in for x that would give me a true statement. What's one, John?
17.
17 would work. Give me another value. 15, right? How about another one? How much?
Did you say you love me?
600.
Did you say you
Okay, there's a lot of solutions here, right? Basically, x can be any number greater than what value? 2. Now, when we represent this on a number line right here, guys, I'll show you what this looks like on a number line in a second. But, guys, when we reference stuff on a number line, or when I say graph it, I'm going to make your graphs very general right here. First of all, we're comparing all of our answers right here that would make a true statement to what value in there? 2. So all I do is I come in here and I mark 2. Okay, and then I want all values greater than 2. Well, I heard 17, I heard 600, I heard 30. Where are all those values at in relationship to 2 that would make that a true statement? To the left of 2 or to the right of 2?
Right.
They are to the right of 2. So where would I scribble to include those values?
To the right of it.
Okay, now we're going to talk about 2 as a reference value in our solution. We're going to talk about open and closed dots on 2 and what that stuff means. Remember when we talked about intervals a little bit?
Yeah.
Okay, would this have an open dot or closed dot on 2? It's open on 2, wouldn't it? Okay. When is it closed? When there is an equal sign here. So here's what we're doing today, guys. we're going to start looking at inequalities as they're in some kind of a form of an inequality that we have to solve like an equation. And we're going to have to do a little bit of graphing, but I think that if you can take that what we looked at in the last couple of sections and tie it to these graphs right here, you're going to be in great shape. That's all we're doing is mixing the two together today now. So, our goal for the day, excuse me, our goal for the day is to understand how adding, subtracting, multiplying, and dividing affect, this should say the word and right there, I should say and, not and. How they affect an inequality and model situations with inequalities, okay? This word should be and. All right. Guys, down here in our vocabulary, we've talked about this before. We've had this toolbox in the past, this year. Just a quick reminder. Sounds like you have it over there.
I feel like we're in the woods.
I do.
I feel like we're in the middle of a
This is a
scary
scene from
movie.
The Hungry and for Rude Eyes.
The witch is
Yeah.
gonna come out and get me.
It's like the music from the Blair Witch Project.
It is. Which may be one of the scariest movies I've ever watched.
What movie?
I'm serious.
What movie?
I just,
Blair
that
Witch
kind of
Project.
stuff
Carson, what
freaks me
movie?
Is
out.
it about like,
What
All right.
movie?
well, yeah, it's about like woods.
What
It's
movie?
college kids go in there and like try and
What movie?
I think it's freaky because it's from a perspective of almost like reality TV.
What movie? Bree, what movie?
Blair Witch Project. Go watch
I've
it.
never seen The Crucible. I haven't ever seen it, but I'm
I like
excited.
movies Conjuring.
All right, let's get back on task here, guys, and run through these here quickly. I don't want to spend a ton of time on this, so here we go. Guys, what's this sign simply mean?
Less than.
And when we graph anything that has less than a solution, what kind of dot does our reference value get?
Open.
Open. We're not going to include that value as one of our solutions. That's all it means. This means greater than, what kind of dot?
Open.
Okay, these two, pretty much the same thing. Less than or equal to, greater than or equal to. These equal signs say closed dot, so that means I'm including or not including the reference value as part of the solution. If I close it, you do what? If you close it, it's actually included. Shaded in means it's included, okay? All right, so let's start looking at it. This is a toolbox. We've seen this before. We've done this before, but the reference is there for you to go back and say, I can't remember what the signs mean, or I can't remember if the reference value is open or closed. The way I remember is this. If there's a line under it, close it in or shade it in, okay? All right. There's a big rule right here. It says solving inequalities is just like solving what?
Equations.
With one exception. Here's the dealio. It says when multiplying or dividing by a negative number, okay, what kind of a number?
Negative.
Multiplying or dividing by a negative number, you switch the sign of the inequality, meaning that a less than might switch to a greater than. Or a less than or equal to might switch to a greater than or equal to, okay? If we're ever solving these right here and we run into the situation where we say we have to multiply or divide by a negative number, switch the inequality. So let me show you what I'm talking about here real quickly. I might have something like this. I might have something that says 3x is greater than negative 6. And you don't have to write this down, just pay attention. I might have negative 3x is less than maybe 12. Okay. Guys, when we start looking at this stuff right here, the only difference from what we've been doing to what we're going to do now is that you no longer have an equal sign. Don't you have like a less than or greater than sign here now? We're trying to find multiple solutions that would make this a true statement. Guys, if this was like 3x equals negative 6 right here, what would you do to both sides? What would you do to both sides to get x along? Not minus. That says 3 times x, doesn't it? Divide by what value?
3.
Dividing by 3. So I would divide by a positive 3. This is the step I'm talking about. Am I dividing or multiplying by a negative here or a positive? The step I take, or the process that I imply here, or implement I should say, is to divide by a positive. If I divide by a positive, will this switch? No. Okay, what the rule we underlined say? If you multiply or divide by a negative, the sign switches. Here you're dividing by a positive, so this would just be x is greater than, what's negative 6 divided by 3? Well, it's negative 2, isn't it? I don't switch this sign because we divided by what kind of value in the bottom? Positive. Now over here, what would you divide by? Negative 3. This is different. Anytime you divide by a negative 3 in this step right here, you're going to have x over here, but since you divided by a negative down here, less than is going to turn to what? This will turn to greater than this time, okay? And what's my reasoning? What's the rule I just gave you? I'm dividing by a negative. And then to get a solution here, what would 12 divided by negative 3 be? Negative 4. Okay, so just keep that in the back of your mind. The only thing that's really different is this. We're going to do everything exactly the same as we have in the last couple of sections. The only thing we need to say that's kind of new is this. Whenever multiplying or dividing by a negative number, as you process these problems, that's when you're going to have to switch that sign. Okay? So back to this page right here. I'm going to read through this again one more time. It says solving inequalities is just like solving what? Equations. The only exception being is when you multiply or divide by a negative number, you have to switch the inequality sign. Okay? So let's look at some examples here. Okay? Solve and graph these puppies. Basically, we have to get x alone. Right? First one says x plus 5 is less than negative 2. X plus 5 is less than negative 2. What are you going to do here to get x alone? Subtract 5. Okay? Does it say anything about switching the signs up here under adding and subtracting?
No.
So if we're doing addition and subtraction, this less than will stay a what?
Less.
Less than. Oh, no problem. Here's how this works. Okay, I'm going to put a minus 5 on the left. I'm going to zoom up a bit on this. I'm going to put a minus 5 on the left. So we'll go minus 5 here. And we'll go minus 5 here. Okay, help me out, minions. What are the 5s going to do on the left? They're gone. What are you left with? Okay, now I don't have an equal sign in here anymore. This is where kids just get into old habits. They just put an equals down here. But what sign do you really have up here now? Less than. I don't change that because we were just doing subtraction, right? So bring that straight down. Now, on the right side here, we have negative 2 minus 5 more. What is that value?
Negative 7.
Negative 7. So my solution, you guys are done with the problem when you've isolated x. All right? So we're saying this inequality, the original inequality, would be true if all x values are less than what?
7.
Negative 7. So it said to solve and do what? Solve and do what?
Graph.
Okay. I don't want your graphs to be too technical. So all you're going to do for the graphing part of this is the following. Just kind of sketch a number line. Okay. I don't care what that number line looks like. Mine's not very good. Okay. I didn't make a very nice number line. Okay. What are we comparing our x values to in our solution here? Negative 7. So all you're going to do is draw a line anywhere. I don't care where that line is. I'm going to put a line right in the middle most times. And what am I going to reference that value as?
Negative 7.
Negative 7, okay? Once I've got my reference value on that number line for a graph, I need to ask the question. If we're starting at negative 7, will we be open or closed on negative 7? Open, okay? Now, we need to shade values that are less than negative 7. So if negative 7 was a temperature outside, give me temperatures that would be lower than negative 7.
Negative 9.
Negative 9. Negative 20. Negative 65 degrees below 0. Where are those numbers that I've got as examples? John's negative 9. I heard negative 20. I heard negative 65. Where are those values going to lie in relationship to your reference value of negative 7?
To the left.
To the left. So where are you shading?
To the left.
There it is. Pretty easy, isn't it? Honestly, this is easier than the last section, isn't it? Yeah.
You're not in spirit.
9. Okay, let's do the next one. Hey, gotta get x alone. X minus 6 greater than or equal to 5. How are you gonna get x alone? Add 6. Lauren, can I ask you a question? If I add 6 to both sides, do I switch my sign or keep it the same?
Undo.
Okay, so Lauren says add 6. Add 6.
I know what that means. It's like
John, talk me through this. What are the 6's going to do?
Cancel out.
Gone.
The X.
Signs stay the same or switch? 5 plus 6.
11.
X greater than or equal to 11. So we're saying that any value that's equal to 11 or more than 11 would satisfy the original inequality. So give me a number that would work in this situation. 11 works. 12 works. Does my favorite number of 31 work?
Is it closed because there's a line?
Is it close because there's a line there? Somebody answer that question for us. Are we including 11 as a solution?
Yeah.
Because 11 is equal to 11, right? Satisfies that condition, right? So to answer your question, Lainey, you betcha. So draw your nice little number line. There's my nice little number line. What value am I going to reference?
11.
Open or closed on 11?
Closed.
I like to color. We're coloring in class. We are simply just going to color.
Yeah.
All right, how about, how do I represent that graphically then? Shade right or shade left?
Right.
Because the values that we said would make this inequality true lie
Right.
to which side of our reference value? You said to the right, to the right. Oh, that's a pretty little arrow. Look at that thing. That's a good one. Woo-hoo! Artiste. You know what? Maybe I can sign that right there. Someone will buy it for like $6 billion and I won't ever have to work again.
Do it.
Should I sign it like an artiste?
And like really cool.
Sound like Jay
fancy,
Cutler.
where you can barely tell it's even a P.
I like it.
Can't even tell it. It looks like a
Is
J.
this Justin Parsons?
That's when you know.
Yeah, but most artists.
That's when you know it's good.
That's when you can't read the signature.
I could probably write a prescription with that signature and any doctors know too, couldn't I?
Yes, you could. I'm pretty sure that would just go like, what the heck?
Okay.
It's like,
All right. How you guys feeling about this so far? Pretty good? All right, let's rock and roll. Let's rock and roll. You guys have the first page down? Page 2, please. Okay, let's see. Now, I'm not going to get too much more into the graphs. I really just want to look at some examples for solving. Guys, here's the question. I should back up to this and tell you what's going on here. On this right here, when it says to solve in graph, this part right here is the solved part. You are solved when x is all low. Does that make sense? That's the solving part. This is the graphing part right here. Everybody cool there? Questions to this point? Okay, let's run through these examples. I want some volunteers to talk me through this because I frankly don't know what I'm doing. Okay, so the first one here, gang, says 5 times x is less than what here?
You want it?
Okay, so what operation am I trying to undo in this example? What operation am I trying to undo in that first example? I guess if I had to ask you this question, what would you do to both sides to solve it? Divide by 5. What kind of 5 am I dividing by? Because remember, multiplying and dividing, that's the tricky issue where we might have to switch. Dividing by a positive. So I'm dividing by a positive 5 right here, right? Let's see. When I divide by a positive here, will less than stay a less than or change to greater than?
Be negative 8.
Well, don't give me a solution yet. I want to know, will the inequality stay the same or will it switch? It's going to stay the same because we're dividing by a positive. What are the 5's going to do here? How about negative 40 divided by 5? Negative 8. Very good. Right? Now if I was graphing of that, just tell me, open or closed on negative 8? Open, right? Shade left or shade right? Left. The number's less than negative 8, right? Okay, I'm not going to draw that in. You can do that, okay? Reference negative 8, open on negative 8, shade left. Value smaller than negative 8 would be left. Okay? Slide over to the next one, please. I'm going to rewrite this problem. This is really x divided by 4 is greater than what? Well, greater than 12. Okay? So if I want x alone, aren't I undoing division of 4? So times by what, Lainey? Times by 4. times by 4. Multiply by 4. Multiply by 4. All agree? Close. What's 12 times 4? 40. Jimmy Johnson's number, right? Lowe's Chevrolet. Important part that says Chevrolet, right? Right, well, what 4 is going to do here?
That's my hand.
Yeah, you're in school.
Okay, everybody listen up, please. Stay with me. Greater than or less than here? Multiplied by a positive 4. Stays the same, right? I'm not going to graph it, but does somebody just describe to you what the graph would look like here? I'm not going to graph it, but what would the graph look like here?
It's gonna be an open, closed.
Open on,
Open 48.
open on 48 and shade to the right. Very good, Brittany. Open, shade to the right. Good.
I need to watch Pirates of the Caribbean.
That is
Awesome. Okay, never mind about that. Okay. Okay. Well, let's get going here then. Let's start looking at some examples, maybe where the sign does switch. Is this the next one right here?
Yeah.
Okay, this is where things get kind of tricky. All right. I have negative 3x less than negative 39. Now check it out, guys. I'm going to divide both sides by negative 3. Okay. Now this is the one right here where you might want to put a star by it and say, okay, something's happening. All right. First of all, the negative 3's on the left will cancel, right? So the solving part, x is alone now, but this is where you are dividing by what kind of number? Divided by a negative, right? Okay, divided by a negative. So what's going to happen to your less than sign? You're going to change it to, that's that one rule that says, hey, we got to switch that, okay? Nope, nope. If there's no equal sign in there, you don't put it in there, okay? Then, how about negative 39 divided by negative 3? What's that going to be on the right side? 13. So my solve part is x greater than 13. Explain to me why this sign switched right here. I should be able to call on anybody. Why did this sign switch? Divided by a negative.
So when you divide or multiply by a negative.
That's the only time it's going to switch. Good to go? Okay. By the way, open or closed on 13? Right or left of 13? Okay. Next one. This says x divided by, I'll rewrite it. I don't like the way it's set up here. X divided by negative 6 is less than 88. Okay. Lainey, can I come back to you on this one? What are you going to do to both sides here? Going to multiply both sides by negative 6, right? Negative 6 is what are they going to do? What are my negative 6s going to do on the left? Got x here. How about my sign? Why am I switching, kiddo? Multiplying by a negative. Everybody see I'm multiplying by a negative?
Yeah.
Multiply or divide by a negative? That's the situation you run into. Less than becomes a greater than. Ah, boy, I don't know what 88 and 6 is. 528? Negative 528. Very good. By the way, gang, open or closed on negative 528?
Open.
Open. Numbers bigger than negative 528. Right or left of it?
Right.
Right. Okay, good. Good, good, good. All right, so let me run into a couple, what is it, 2 more examples on this? Yeah. Let me run through these 2 examples. We'll see what's on the next page here. And the next page has got a couple of on your own, doesn't it?
What's for lunch today?
Mac and cheese.
Soup, apples, chips, and pop.
What kind of soup?
Potato and broccoli.
I love potatoes.
I brought leftovers and they're in the
Okay, hey, check this one out with me. Guys, this is almost a 2-step equation. If this was like an equal sign, what would be your first step in solving this right here? Add a 6. Does addition or subtraction change my sign?
No.
No. Okay, so here's what I'm going to write on the left. 6's will. Cancel. So what am I left with on the left side so far?
3x.
And you said addition wouldn't change this, so bring my greater than sign down. 21. Now what? Divide by 3. X is greater than. That's pretty easy, isn't it? All right, solve part. And again, I think we've done enough graphing in here. You should know what to do when it says graph. Okay, what's involved in the last problem on this page that we haven't looked at yet? Parentheses. So what property might I have to choose to apply here before I can work with this? Yeah. So here we go. 4 times what here, gang?
4x plus 4y.
What's 1.5 times 4, guys? 1.5 times 4. 6. 4x plus 6. Less than what? Less than what value? Okay. Next step. Somebody tell me what to do. Okay. And I don't even have to do that. Although that's great that you recognize that. Do I have to even do that though, Lauren? No. Nope. So how about after that step? Where do you want to go, kiddo? Yep. Okay, good. Well, okay, Lauren, I'm going to leave this one up to you. Finish it off. So I'm going to have what on the left first of all, kiddo? Sign changing or still the same? All right. And then you said 16, I believe? Okay, Lauren, almost done. All right, dividing by 4, very good. Guys agree?
Yeah.
Guys in the back agree? 16 divided by 4. Okay, real quickly explain to me, somebody other than Lauren then. Open or closed on 4?
Close.
Open.
Open.
Oh, I heard both. Which is it?
Open.
Why?
Because it's not an equal sign.
Not including 4, are we? Right? Left or right? Of 4.
Right. Left. Sorry.
Give me a number in here that would make this statement true.
3.
3. Where's 3 going to lie in reference to 4? Straight and left. Very good. Okay. Last page here quickly, kiddos.
Yuri. I know.
All right. It says Yuri has 17 minutes of music on a 90-minute CD. It says how many 5-minute songs can he still get on that CD? Okay. Here's the deal. I go out and buy CDs, and it says CDs. Yuri must be a cousin of Siri.
No, Yuri is notarized.
Oh, really? Do you know what I call the Google lady that talks to me? Iris. It's Siri backwards.
Sometimes
Does she call you
I
anything?
change Siri to
Actually,
Diamond.
Iris in my phone, like when I'm driving, Iris talks to me when there's texting, so I don't even pick it up. It'll
Don't
say,
you say like, hey, like Siri, wait, can you change your name?
Yeah, you can be like.
You have to change your name. Be like,
well,
call me.
and when I'm in my car, it knows that I'm driving, and when I get text, it'll start reading the text. It'll say text from Mindy. To hear it say listen, I'll just say listen, and it'll read the text. And it says reply back to her, speak now, and I'll speak, and it'll say, okay, I think you said blah blah blah, and it'll say, do you want to send it? I'm like, yep, send it.
Your wife's name is
Does
the
she
baby.
ever pronounce someone's
Huh?
name like?
Wife's contact is
Yeah,
the
I
baby.
see.
No, my wife's name is Mindy.
I know, but
The contact name is Mindy.
it's not baby.
No,
Not the baby.
I was trying Siri. I was
it
trying.
would be smoking hot.
The wife. The smoking hot
It would be
baby.
smoking hot. Like that. That's what I was going to change it to. All right. Okay, Gary has 17 minutes of music on a CD already. Now, these CDs only hold how many minutes of music?
90 minutes.
That means I can have up to 90 minutes or less than that, right? Okay. We're adding some songs here, right? Each song that we're going to add is how long, gang?
5 minutes.
Okay. So I want to model this example in the form of an inequality and show you how this works. So here's what we're looking at. First of all, you already agree we have 17 minutes of music on this disc, right? That's the amount of music that he's already purchased on that 90-minute disc, right? He wants to go into, say, iTunes, buy some more music to burn to his disc, all right? He knows that he can burn a certain number of songs. Guys, do we know how many songs he's going to get right off the bat?
No.
What do you suppose we're going to let X represent?
The songs.
X is going to be the number of songs he can put on. Okay, but each song was how many minutes long? So I would add an expression to the 17 minutes on there. I would add 5 minutes for each song. How many songs again? 5 times X. 5 minutes for each song that he's going to add to that. Now, we want this expression. This expression can't exceed what value? So can it be equal to 90?
Yeah.
Can it be more than 90? So this expression has to be less than, or it can be equal to what?
90.
Okay, so the question says, how many 5-minute songs can we fit on this CD? Well, this is an interesting problem because when you start talking about inequalities as they relate to real situations like this, your answer that you get, you want to put it in a way such that it makes sense in terms of what the question is asking. So here's what we're going to do. We're going to go ahead, we're going to apply what we know about solving inequalities first, but then we're going to talk about how does that answer relate to the situation we're in. Okay? So help me out here first. What would be your first step for solving this? Minus 17. Let's rock and roll it. Boom, boom, bam. I've got 5x less than or equal to, all right, I'm not very good at math, but I think 90 minus 17 is 73. Okay, so I would take 73 and divide this by what now? 73 and divide by 5. Okay, I'm not sure what that is. Well, I do know what it is off the top of my head. 14 point what? I didn't want to do that. But I can clear that.
You're not very good at math.
I'm not. I was better at science than I was math. Okay, 14.6. So we're saying this right here, guys. We are saying right here, how many 5-minute songs can we still get on the CD? Well, the answer I got is X is less than or equal to 14.6. Okay, now think about this, guys. When you put 6/10 of a song on a CD, when you get to your computer and start burning, it's going to say you're out of what? Room. You can't put this many songs on there, right? Okay. How many whole songs could he burn according to this? 14. Could burn 14. Now, I understand that when we solved the inequality we wrote, 14.6 is the number we get. But if I think about this problem in real life and say, what's the question asking? What's this value mean? How do I answer this question intelligently? What should I really say about this? How many 5-minute songs can we still get on the CD? What would you say? You could say he can get up to how many? 14. So you understand how taking this right here and saying, okay, this is the number I've got. Now how do I use that information to answer the question? You could say he can get up to 14 whole songs. Does that make sense, gang? Okay. Yeah, we know how to solve inequalities, but now I want you to make sure you see what solving an inequality means as it relates to a real life problem. So take what you get in the solve part, use that information to answer your question intelligently based on what the question is asking. Okay? Are you okay with that?
Yes, sir.
All right. Last one. You guys have this down? You guys got it down? Okay. Last one says Joe has $123 in an account. Right? It says with the extra earnings from her job, she can deposit $50 per what? It says when she reaches $500, she plans to do what? It says model and solve this, and then ask yourself how long she must go in order to open up a savings account. Okay, I don't know why I put she in there. Joe must be a she today. That's okay.
I know a girl named Joe.
So do I.
So did you
But
call
there's no
the name
E on it.
Yuri? Cousin of Zuri?
Huh?
My name is Iris.
Iris.
Bill.
Zuri.
Okay, how much money does Joe have already?
123.
Okay, so again, the question says how long or how many minutes will she go in order to open a savings account? Well, she's going to add some money to that. We need to find a number of weeks. So again, we'll let X represent a number of weeks, but how much money is she adding each week?
$50.
Adding $50 per week, right?
Yep.
Okay. It says that when she reaches $500, she'll open a savings account. Okay. Now, when she reaches $500, that means $500 that she's going to get to, or she'll have more or less than 500.
More or less.
More, right? So I want this expression to be either equal to $500 or I want it to be more than $500. I can open an account if I have 500 or more here, right? So we're going to compare that to the $500. Okay, now she's only getting $50 each week. Are they going to pay you every single day, or are they going to pay you by the week? Okay, so let's solve this. I'm going to subtract 123 again. And when I do this, I have 50x is greater than or equal to, oh, what is that, 377? Let me check. I'm going to go 500 minus 123. You guys agree?
Yep.
Whoops. Okay, what value is that?
7.
377, right? Now what are you going to divide by?
Gonna get 7.5.
Okay, so here's the deal. This is saying x is greater than or equal to 7.54, which implies that 7.54 weeks she's going to have $500, right? But now let's think about what the question is asking. It says, how long must she go in order to open a savings account? Well, they're going to pay you every single week, right?
Yeah.
Are they going to pay you after 1 week? Yes. After 2 weeks? Yes. After 3 weeks? Yes. Are they going to pay you? If I went down to the office right now and says, hey, it's been 0.6 weeks since my last paycheck, pay me up till that now, are they going to pay me?
Probably
No.
not.
Are they going to pay you at 7.54 weeks? When do you think they're going to pay you? 8 weeks? Would 7 weeks work here?
No.
No, we want our value to be greater than or equal to what value here? 7.54. So how do you take your solution right there and relate what you have solution-wise to answer the question? What would you say? Question says, how long must she go in order to open a savings account? What would you say as it relates to 8 weeks or what? Okay, so you might say she must go at least how many weeks?
8.
At least 8 weeks. Okay, does this make sense, kiddos? What questions have you got for me? What questions have you got? Okay. I had assigned page 2, what was it, 266 now? 1 through 19 and 21 due for when? Tuesday, okay? I guess that what I'm going to ask you to be doing right now is to be starting on that.